All right, welcome to section 5.3 on some theorems that involve parallel lines. If it looks like I'm doing this in a garage, maybe I'm doing it in a garage. Just don't ask me questions about that. This does have everything to do with quadrilaterals. It'll make a lot more sense, I believe, in section 5.3, but these three things are important for us to learn first. So let's get after it. Part 1, first piece of this puzzle. If you have three or more parallel lines that cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Here we have three parallel lines, and they cut off, from what's given here, two congruent segments. Segment AC is congruent with segment EC. Because it cuts off congruent segments on this transversal, it has to do the same thing on this transversal. So if these two pieces are congruent, so are these. BD has to be congruent with DF. If we created another transversal, those pieces would be congruent as well. Has nothing to do, the transversals don't need to be parallel or anything like that. These lines have to be parallel, and then we end up with congruent pieces. That's all there is to it, but let's look at the examples. Example 1, here we have three parallel lines, and those parallel lines cut off two congruent segments. So if these segments are congruent on this transversal, these have to be congruent as well. So NT is equal to TZ. Now the question gives us information about NT and NZ, the whole of this segment. Well, not the whole, well yes, the whole of segment NZ. So NT is half of NC, or two of them together equal the whole segment. You can solve this using the segment addition postulate, which is what they have chosen to do here for us. So they said segment NZ, 3x minus 8 equals segment NT, x plus 6, plus segment TZ, which is also going to equal x plus 6. They've solved that to figure out that x is equal to 20. Okay? Or we could have said that two NTs will equal 1 NZ, right? Because this is half of it. And we would end up with the same really equation. See how this has 3x minus 8 equals 2 of these? Well, that's what this would do as well. You'd also get x equals 20. The question asks you to solve for x, then the length of NT, TZ, and NZ. So then, of course, we would need to plug in x into these expressions to get our answer. Now, if we extended these lines, notice that they would intersect out here, and we actually would end up with a triangle here, a little bit bigger triangle here, and even bigger triangle. But if we state that these segments are congruent, then that means that these are as well. All right? So one of these would equal two of those. I'm setting you up for something that's going to come here in just a little bit. All right, here's a set of questions that use this theorem. We've got four parallel lines in this diagram. If AB is congruent to BC is congruent to CD, then these pieces have to be congruent as well, PQ, QR, and RS. Use that information to see if you can answer 1 through 7. Pause the video first. Okay, how did you do? Figure out which ones you have questions about. Part 2. A line that contains the midpoint of one side of a triangle is parallel to the other side, and is parallel to the other side, passes through the midpoint of the third side. This is a very related idea here. But if we know that M is a midpoint of segment XY, okay, and we know that MN is parallel to YZ, what that is telling us here is that N also has to be a midpoint. This is really no different than what we were looking at in that previous picture. In fact, let me back up to this. In this picture here, if we just look at this triangle right here, these two pieces, if this is a midpoint and this is a midpoint of these segments going from this point to Z and to Y, then those lines have to be parallel. That's another way of looking at what's going on here. So if we look at an example, oh, by the way, yes, mid-segment. This is what this segment is called. MN is now what's called a mid-segment. That's a word that we are going to talk about with frequency in the next several sections. All right, so for our example, this is a type of question you'll see out of this here. The things that you need to be looking for are midpoints and parallel lines. Okay? So in this example, name all the points shown that must be midpoints of the sides of the large triangle. So based on what's given, since AM is congruent with MB, M has to be a midpoint. Okay? M is a midpoint. And because MN is parallel with BC, if the segment MN starts at this midpoint and is parallel to the third side, N also has to be a midpoint. That is this in action. If M is a midpoint, then N also is a midpoint because of the mid segment that it is parallel to. Let me do number 8 with you. First of all, let's see. Do we have parallel segments? We absolutely do. AC is parallel with XZ. Do we have a midpoint? Yes. CZ is equal to 6, YC is equal to 6. So C is a midpoint. Okay, now AC goes from a midpoint to the other side and is parallel to the third side. So therefore, A also has to be a midpoint. The two midpoints are C and A. See if you can answer 9 and 10. I'll give you a clue. There has to be a midpoint over here, and then we have parallel lines here. I fully expect you to try these on your own, and then here are these answers. Assuming you're paying attention, above the word geometry right up here, please write winter. It's been cold. Write the word winter up there, please. Last piece of this puzzle. A segment that joins the midpoints. What do we call that segment that joins the midpoints of two sides? We call that a mid-segment. So if you have a mid-segment of a triangle, it is parallel to the third side, okay? And it is, it's good to know that if it's parallel, then it's going to create corresponding congruent angles there. And it is half as long as the third side, okay? So if M is a midpoint and N is a midpoint on our triangle up here, okay, then we know that it's parallel and we know something about its length. We know that they're parallel and we know that MN is equal to 1/2 of YZ. Now what you just saw me write up this is that the third side is twice the length of the mid-segment, okay? So we can either say that MN is equal to half YZ, or we could say that 2 MNs is equal to YZ. I am going to encourage you to use this one so that you don't ever have fractions. Okay, so look at example 3. If A and B are midpoints, then that tells us that AB has to be parallel to ST, but with respect to their lengths, that allows us to say that AB is equal to half ST. Or that 2AB is equal to 1 ST. So I beg your pardon, I just had an interruption here that I had to deal with. I think where we were was saying that here, to solve for x, if we have a mid-segment, either this segment AB is equal to half the length of ST, or 2 times AB is equal to 1 ST. They chose to do the half thing. I say do the 2 times thing. That way you can avoid fractions. But either way, you get 48. You get 38 for x with either of these equations, and then you plug in 38 to find the length of ST or AB. The key to this third section of things is if you have a segment that goes from midpoint to midpoint, a mid-segment, its length is double the length of the third side. So use that idea to answer these next couple questions. Okay, so here MN is going to be parallel to YZ. That comes when we're talking about the questions about angles. That's going to come into play. But 2 of these equals 1 of these. I hope that you paused, and I hope that you got these answers. Be prepared to ask questions if you have them, and be restful, people. Okay, bye.